Hi everyone, my name is Reagan and I'm a Senior Data Fellow for FSU Libraries. And today I'm going to be teaching you an Introduction to Git and GitHub workshop. So today we are going to cover why you should use Git, how Git works, how to install and configure Git and GitHub, how to push your code with Git, and then we're also going to do some file examples using Git and GitHub, and we're just going to explore some of the important concepts from Git. So what is Git? Git is a free and open source distributed version control system developed by Linus Torvalds in 2005. Git is used to help you manage code in a project as you develop new features and fix bugs, and it simplifies collaboration with other developers, and it has a really great support with branching, merging, and pull requests, which I'll be discussing a little bit later on, which allow teams to collaborate and efficiently work with each other's code. So while allowing developers to work simultaneously, it also will prevent overwriting each other's changes, which is very important. And it can be used for tracking code changes, tracking who made those code changes, and for code and collaboration, like I was saying. And today we will be setting up your Git and GitHub and practicing using them together. So now let's discuss the differences between Git and GitHub. Git is the tool that helps you keep track of changes to your project and manages your project's history on your local machine, while GitHub is a website that you can use to store and share your Git projects publicly and privately. GitHub is essentially a hosting service for Git repositories that has a more user-friendly interface than the terminal. So many developers will use both Git and GitHub at the same time to maximize their productivity and collaboration efforts. In addition, there are other Git hosting services that many developers may use for other different purposes, such as Bitbucket, but today I'm just going to be focusing on GitHub. So why should you use Git? Git is a software that keeps track of changes that you made to files and directories. It can keep track of changes to code in your repository and who made those changes. For example, if you're editing a file, it will keep track of each version of that file for you, so that you can move back and forth between versions if you need to. For a company-wide project, for example, this is great for adding new features or fixing bugs, since Git supports branching and merging. And this software is known as version control system and is used to manage source code. So why is Git better than other version control systems? A version control system is a tool that helps manage changes to documents, programs, and other information stored as computer files. A distributed version control system not only tracks changes, but also tracks the repository's full history on every user's computer, allowing for operations like commit, revert, and branch. There are several version control systems available. However, a popular opinion is that Git is the best one for a number of reasons. Git has a branching functionality that allows for collaboration that is not possible in a lot of other version control systems. And Git is also free and open source. It also enables multiple developers to work together on nonlinear development. Also, since Git is a distributed version control system, it allows for different users to maintain their own repositories instead of working from a central repository. Each developer has a copy of their entire repository, including commits, branches, files, etc. So how exactly does Git work? Git uses repositories as the fundamental unit for managing projects. A repository, or a repo for short, is essentially a folder that contains all of the project files and the revision history. These repositories can be local, which would mean like on your personal machine, or remote, which would mean stored on a server or a platform such as GitHub. You can also clone a repository from GitHub onto your local machine, which sets up a connection that allows you to push your committed changes back to the remote repository, facilitating a seamless collaboration. Git tracks changes in a two-step process, which they call staging and committing. Staging involves selecting changes that you want to include in your next commit, and committing takes those staged changes and records them in the repository's history. Branching creates a separate line of development within the project, allowing you to work on new features, bug fixes, and in isolation from the rest of the project. Once the work on a branch is complete, you can merge it back into the main branch, which would integrate those changes that you just made. This facilitates concurrent developments among multiple team members and helps manage project complexity. With branching and merging, you can also pull the latest version of the project onto your local copy or your local machine or you can push your local changes into the main project. So how does GitHub work? GitHub is a web-based hosting service for Git repositories. It is a cloud service that hosts Git repositories, making it easier for developers to store, manage, and share their code. Since it's web-based, it allows for remote access to projects from anywhere, facilitating global collaboration. While Git can be used on its own for local version control, GitHub requires Git for repository management functionalities. This emphasizes the dependency of GitHub on Git's system for version control, even though GitHub essentially can extend on Git's capabilities with additional features. As the largest repository host, GitHub has become a central platform for open source and private company projects. It hosts millions of repositories, making it an essential tool for developers worldwide to use and contribute to software projects. Also, this collection of code is a great learning resource. In addition to Git repositories, GitHub also provides a platform for developers to share code snippets, issues, and documentation. Also, in order to collaborate on code using Git, you must use GitHub or one of those other platforms that I was talking about previously. So now I would like all of you to take a few minutes to install Git. If you have a Linux or a Mac computer, it should already be installed in your terminal, and you can check this by going to your terminal or command prompt and typing in Git to make sure that it's installed properly. And if you're using a Windows computer, go to git-scm.com, or if you look up Git download for Windows, that will show up as well. And then you're just gonna follow those steps to install Git on your computer, and it will also give you some options to customize different things and things like that, but just follow those instructions in order to install it on the terminal or command prompt. And then once you have it installed, and you would check this by typing in just the word Git to make sure that it returns the Git version, you can configure Git. So you would configure it with your name and email address using the terminal or command prompt, and you would type in these commands that I'm showing on the screen, filling in your name and your email address. And also, I know it's a little bit hard to see in the slide, but there's 2 dashes before the word global in those commands. And then to make sure that you configured it correctly, you're gonna type in the git config --list command, and you should be able to see what you just configured, just to make sure that you have it all set up properly. And now that you have Git configured, you're going to need to create a GitHub account if you don't already have one. And this is pretty straightforward. You're just gonna go to the GitHub website and create a free account. And my one piece of recommendation would just be to make your username and everything kind of professional, because it's gonna be shown every time you make an edit if you're working with a group. So it's just, if you're working with a group project or something like that, you might just wanna use a professional email and professional username. And you're also going to have to verify your email and fill out any other information that it asks. And now, before we go through an example using Git and GitHub, I wanted to give you some more vocabulary and walk through the steps of creating repositories and understanding the key concepts in Git, as well as working with branches. So the working directory in Git is your local directory on your computer where you are currently editing and organizing your project files. It's where you make changes to your files, add new files, and delete unnecessary ones before deciding what changes to commit to your project history. The staging area is an intermediate area where commits are prepared. It's the place between your working directory and your repository where you can review, add, or remove changes before committing them to your project's history. This step allows you to decide what changes you want to commit. And a repo or repository is a storage location for your project on Git that holds all of your project files and each file's revision history. Repositories can be local or remote, and it serves as the heart of your project, allowing you to track changes, revert to previous states, and collaborate with others. A branch in Git allows you to separate from the main line of development and work independently on a section of code without it affecting the main project. It lets you develop features or fix bugs and keep those changes separate until you're ready to be integrated into the main project. Branching is extremely important in managing larger projects and enabling multiple developers to work on different features simultaneously without conflict. Merging is the process of taking the changes from one branch, or the source branch, and integrating them into another branch, which would be the target branch. This is a crucial part of Git's collaborative workflow, allowing you to combine the work from different branches together, such as merging a feature branch back into the main branch once a feature is complete. And merging can be done via the command line or through a pull request on GitHub. So cloning in Git would mean creating a local copy on your machine of a remote repository, which would be on GitHub, and the clone includes the project's files, history, and branches. It's the first step in contributing to a project that's stored on a remote repository like GitHub, allowing you to work on the project from your own machine. When you clone a repository, you set up a link between the local and remote repositories, enabling you to push your changes back to the remote and also pull any other updates from it. Forking allows you to create a personal copy of someone else's project on your GitHub account, but this won't affect the original repository like cloning will, but it gives you essentially a sandboxed version where you can make changes without needing the original project's permissions. And forking is the first step of contributing to open source projects, where you can make changes in your forked version and then propose those changes back into the original project via a pull request, like I was mentioning earlier. So now I just want to walk through some of the different ways that you can set up a repository. So you can initialize a new repository for existing code, or clone an existing repository onto your local machine. So I'm going to also demonstrate this as well, but I just wanted to read through how to do it first. So to set up a new repository with no existing code using Git, you would do the following. So you're gonna open up your terminal or a command prompt. So I'm gonna do so right over here, which I already have up. And then you can make a new directory using the make directory command, which will essentially make a new folder. So I'll just make one called test1. And then you're going to go into the directory by using the cd command. And then you're just going to type in the command git init, which will initialize a new Git repository in your current directory. And then from there, you can make and add files to this repository. So to set up a new repository on Git with existing code, it's a very similar process. You first open your terminal or command prompt, and then you're going to navigate to that directory like I was showing before using the cd commands. So you're going to navigate to the directory that has your existing project, and then you're going to type in the command git init, like I also just showed, which will, again, initialize a new Git repository in your current directory. But this time, instead of the Git repository being empty, it's going to include all of those files from your current project. So you can also clone an existing repository, and that's another very common way in order to start working on a project. So to do this, you're first going to go to the repository that you want to clone on GitHub. Which you can find through searching, or if someone shared it to you. And then you can click on this green code button at the top, and you're gonna click on HTTPS and copy that URL that it's going to give you. And then you're gonna wanna open the terminal or command prompt, navigate to the folder where you want to clone the repository, and then run the command, the git clone HTTPS, like the rest of the URL link. And then you're also going to need to type in your username and personal access token, which I'm going to touch on later, but that's how you would do it. And I would also recommend that when you're cloning an existing repository, you make a new directory to put this project in, and then go into that directory and then clone it in there. And once you have initialized a new repository and you are ready to add some new files or add updated files to your repository, follow these steps to do that. To using the terminal or command prompt. And I want to emphasize that you need to be in the correct working directory of your Git repository before executing any of these commands, otherwise they're not going to work. So once again, I'm going to kind of demonstrate how to do this and also read as I'm going through it. So the first step is the git add command. So git add moves changes from the working directory to the staging area, and it's like preparing a package of changes that you're about to send off. So git add can be used to selectively stage files, allowing you to control what changes are included in the commit. So for example, if you just made a new repository and you have some files that you're ready to commit, but some that you aren't, you're allowed to kind of select those specific files that you want to include. So like I was saying, this is very helpful for grouping related changes into a single commit. And staging is not the final step. It requires a commit in order to finalize these changes. So really quick, I'm just gonna go back into this like test repository just so I can show you. So I'm gonna just use the Nano text editor to make like a text file. And then I'm just gonna type hello world. And then just save this just as an example. So now you can see that I just made that file in there. And now we're gonna just do the git add command in order to add the text file into the staging area. So as you can see, it just added it. And if I do git status, you should be able to see it. So it says no commits yet, but there's a change that needs to be committed, which is this new file. So the second step is the command git commit. And a commit is a significant milestone in the development process. When you're committing something, it commits all the changes that have been added to the staging area, so everything that was added with the git add command. And the git commit command will permanently record those changes in the repository's history. And it's also good practice to add a message to your commit describing what the commit does or why the change was made, and to only make a commit to code that works properly. So the command to add a message is git commit -m commit message. So I'm going to do the following, git commit -m, and then I'm going to say like first commit. And as you can see, it just made a commit. And then you will also be able to see that in git status. So there's nothing to commit because I already committed everything. So let's go back to sharing the slides. And then since using commit will permanently record the state of the project in the repository's history, you can also revert back to the state if needed, which is also a really helpful feature, and why it's recommended to always commit whenever you have a working version. So git push is the next step, which will allow you to upload your commit to a remote repository, which is the repository on GitHub. And this is essential for collaboration as it makes your changes available to others. So to push to the remote repository, use the git push command, and you have to include the name of the repository and the branch name if you have multiple branches. I also wanted to mention that if you are just using Git as a version control system and you don't need to work collaboratively using GitHub, you don't have to use the push command. You can just do git add and git commit in order to have different versions just for you locally on your machine. However, if you do use the push command, you are going to have to use that username and personal access token, which I'm going to get to in a second. And now I just quickly wanted to show some examples of understanding Git concepts. So on the left, you can see an image that kind of just shows the working directory, staging area, and Git repository, and the different commands that you need to do to get there. And then I'll give you a second to kind of look at the other image on the right, because I know it's a little bit complicated, but it kind of just shows all the different, it's just a way to see all the different like routes that you can take when using Git and GitHub, and how you get from like Git on your local machine into like GitHub, which is the server. And you can do that with like cloning, pulling, and pushing, and that's kind of just showing, that's like the key thing that I wanted to show, is that's how you go from your local machine into the server, and just the different things that you can do in each. So you can also create a new repository on GitHub and push either a new directory or an old directory with previously made code onto it. So this is kind of a way to combine Git and GitHub and doing it on GitHub. So this is common if you already started a project locally and then you decide that you might want to collaborate with someone and you want to post it on GitHub. So to create a new repository on GitHub, you would go to the GitHub website, log into your account, and then you should see like a plus sign in the top right corner, and you're going to want to click that and make a new repository. And once the repository is created, GitHub will give you the URL of the repository, which you will use to push your local changes onto it. So this URL is a link between your local and remote repositories. And to add the remote repository, you're first going to copy your URL that it gives you, and then you're going to navigate to the directory that you would like on your terminal or command prompt that has this already made coding project. And then you're going to use the git remote add command, which I have on the screen. And in this command, origin is an alias for the remote repository URL so that you can make future commands. And when you do this, it will be more concise. So however, if you put a custom name, you can also use a custom name if you would like to. And after using the git remote add command, you would do an initial push command, which is the git push -u, which means upstream, to push your local commits to GitHub. And in this example command, the main part will represent the branch name, which is typically the standard, but if you're using a different branch's name, fill in that name instead of main. And the same goes with origin. If you're using a different name for your repository alias, then replace origin with that name. And once you have the git push command, your project is now going to be on GitHub. So this picture is another representation of just how to use Git and GitHub together, just so you can see like another example of how you have to use like git push and git pull in order to connect to that remote server. So now I want to talk about working with branches. So branching in Git is a powerful tool that enables parallel development, allowing teams to work on different features or fixes at the same time without interfering with each other's work. In other words, branching allows you to have multiple versions of a repository at the same time, which is really important, as I'm sure you can imagine, when you're working in really large group projects or working for a company or something like that. And branching allows developers to isolate their work from the main body of code, which is often referred to as the main branch. So normally you're going to want to work on like a feature branch or something like that when you're making new changes. And in order to create a new branch, all you have to do is this like git branch command with the branch name that I'm showing on the screen. And it's also really good practice to use clear descriptive names for your branches that indicate their purpose. For example, like fix login for fixing a bug in the login page. You don't want to just call it like branch 1 or branch 2 because that could get a little bit confusing. And the command git branch will also list the different branches in your repository. And you can also use it to check what branch you're currently working on because you don't want to accidentally make changes in the wrong branch. And it will put a little star next to the branch that you're currently in when it lists all of the branches. And in order to switch to a different branch, you will use the git checkout desired branch, like the name of the desired branch that you're trying to switch to command. And this command will update your working directory to reflect what you have stored from the project in that branch instead. So as I was kind of saying, different branches can essentially have different like files on them. So that's why it's really important to always make sure that you know what branch you're currently working on. I also wanted to mention that it's a good practice to commit everything that you have in your branch before switching branches to avoid any sort of conflicts or accidentally losing your work. And also, if you're working with multiple branches, you're also going to have to work with pull requests and merging branches because eventually you're going to want to put that branch into another branch, like the main branch, which would involve some sort of pull request and merge. And a pull request is essentially a request in order to merge that future branch, for example, into the main branch. And merging is the final step in that pull request process where the changes from one branch are integrated into the main branch or another branch. So typically from a feature branch into the main branch. And you only want to merge once you've done like testing to make sure that everything will work properly. And there are several different merge strategies, and there also may be something called merge conflicts, which means that like two files might have different changes on them from different branches, and this is going to have to be resolved by the developer. You're going to have to do this like by hand. And then here's just another image that represents branching. So in here you can kind of see like the master or main branch, and then creating a feature branch, and then in which you would commit the changes, make a pull request, and then normally a pull request is kind of like a proposed thing, so you have to get it approved, and you might have to go through some sort of review and make some more changes or things like that, and then eventually it will finally be merged into the master branch. So now I'm going to walk through like this example that I would like all of you to also try on your own, and please let me know if you have any questions. So for the first part of this, I already like have my personal access token set up, but I'm just kind of gonna walk through the steps in order to do it. So first, you're gonna log into the GitHub website, and then we need to set up a personal access token on GitHub. And the reason why you have to do this is because GitHub, they made like a new rule essentially where you have to use a personal access token now that you set up on their website instead of your password for more security whenever you're like cloning or working with something with a remote repository. So this is why it's essential to set this up. And then you're going to want to click on your profile picture and then click on settings, and then you're going to scroll all the way to the bottom to see the developer settings button. And then you're going to click on that, and then you're going to click on personal access tokens and then generate new token. And then you're going to want to give your token a descriptive name under the note and then select like repo. So just make sure that you like keep track of all this information and use like a descriptive name. And then you're gonna click on generate token. And also just so you know, you can only see this token like one time. So I would recommend storing it in some sort of like password vault or something like that. Because they are like quite long and you don't want to lose that and then have to make a new one. It's just kind of a pain. So yeah, so once you have that token, you're just going to want to make sure to store it and we're going to use it later. So now I'm going to go through the steps of creating a new repository. Sorry. And then to do this, you can click this plus sign on the top, and then you're going to click on new repository. And then you're going to want to give it a name. So I am going to do Git workshop. Let's do, yeah, okay. And then we're going to want to make it private. And then, but you can select if you want to make it public. And you can also set up any of these other configurations, like a description or adding a README or anything like that. And then you're going to want to click this create repository button. So now I have my repository, which will also have, it actually will show you the steps in order to initialize a repository as well, or push an existing repository from the command line, which is what I was talking about earlier. And it's also going to give you this HTTPS and SSH different URL codes. So then in the terminal, we're going to want to make a new, let me go back, a new repository. Let's call it my Git workshop. And then we're gonna CD into it. So CD my Git workshop 2. And then we're gonna type in Git init. So now we initialize an empty Git repository. And then we're gonna use nano again to make a new text file. So example, I'm just gonna do hello world, and then save this. So as you can see, I have a new text file inside of this directory. And then we're gonna do git status. And as you can see, I'm gonna need to do git add because it's not tracked. Then we're also gonna wanna commit it. Okay, so now we just committed it. And then I'll do git status so that you can see that it committed and that there's nothing else that needs to be committed. And then we're gonna go back to GitHub. And then we're gonna get this HTTPS URL. So we're just gonna click the copy button. And then we're gonna do git remote add origin and then paste that URL. And then hopefully that means it worked. And then we're gonna do git push -u origin master. And then, so now is where I'm talking about where you're gonna have to type in your personal access token. So I'm just gonna cut that really quick while I do this. Okay, and then as you can see, after typing in my personal access token, it went through. So now the repository is connected with the remote server. So let's go back to GitHub so that we can actually see what happened. So if you refresh it, so now you'll see that the file that I just made in the repository on my local machine is now connected to my remote repository, which is great. And so now let's see what happens when we change a file. So we can go back to the terminal. And we're just going to change this same file. So we're going to do nano example.txt, and then let's add a new line. This is a Git tutorial. And then, so because, oh wait, just kidding. We actually have to do git add again. And then we're going to do git commit again, second commit. And then we're also going to do git push. And then I'm going to need to type in that username and password again. And now let's see if on the remote repository it updated. So it did. So you can see the changes that I've made, which is honestly really nice. And you can see that it's under like the second commit. So you can see like the commit message and everything. And so now let's try what happens if we add a new file on GitHub. So if we go back to this, so let's see if we add a new like text file in this, and I'll show everything. So we're gonna create a new file. Third Git workshop. Let's name it test2.txt. And then let's commit the changes. And then just so that you can see what it's going to look like if we create a new branch and start a pull request, I'll do it, and then we're just gonna leave it with what it suggests, which is Reagan-Born-patch-1, and proposes changes. Okay, and now, so this is what it looks like when you're creating a pull request on GitHub. So you have all of these different like features and things that you can set up. But because it's just me and this is just a test, I'm just gonna create this pull request to add a new file. And then on GitHub, it will automatically check if there's gonna be any merge conflicts, but luckily there isn't because it's just me adding a new file. So I'm gonna merge that pull request. And then you can also add like another commit message or any other things. Like you can really configure this to exactly how you want it to be. But obviously this is just a test, so I'm just gonna leave it as is. And then yeah, as you can see, the pull request successfully merged and closed. So you're gonna be able to see this in the code. So as you can see, there's now a new file with what I typed in it earlier. So that was just a little example of how to see that. So now, essentially, the version of our repository that we have on the remote server is going to be different than what we have on our local machine. So obviously, we want the most updated version. So now what we're going to want to do is go back to the terminal, and then we're going to type in the command git pull in order to get that new version. And as you can see, I have to type this in a million times, that personal access token, so you definitely don't want to lose it. And then let's do ls to see that it was pulled, and as you can see, it was. So that's just a little example of how you can use GitHub and Git together, and how you can kind of use this with collaboration. So let's go back to the slides. Okay, so I already did all these things. So now let's talk more about git pull and pull requests. So in a collaborative coding project, it's crucial to ensure your local repository is synchronized with the remote repository. This ensures that you're working with the most up-to-date code, preventing conflicts and duplicates in your work. Git pull will fetch changes from the remote repository and merge them into your local repository. This command is essential for incorporating the latest updates made by other team members into your local development environment. The git pull command is essentially a combination of two commands, git fetch and git merge. First, it will fetch updates from the remote branch, and then it merges these updates into your current branch. It is a good practice to regularly perform git pull to keep your local repository current, especially before starting new work. And if you're working on a project with lots of other people working on it, you always want to make sure that you have the newest version, because otherwise you might run into some merge conflicts. So also, when merging branches, there may be some problems known as merge conflicts, where two people accidentally edited the same code, for example, and you're going to have to resolve this manually. And it can sometimes be a little bit tricky. And another important topic is known as pull requests. So pull requests, like I was showing earlier, will allow for developers to propose changes to be merged into another branch. And to make a pull request with GitHub, you first will push your branch with changes to the remote repository you want to merge with. And then on GitHub, you're going to open a pull request against the target branch, which is usually the main or the master branch. And then others on the project can review these proposed changes and approve the pull request for merging. And once it was approved, the pull request can be merged into the target branch. So in the example that we did, I kind of showed a merge request like just on GitHub, but this is also something that you will commonly do like with stuff on your local machine. But it's very similar. So now I want to talk a little bit about using the correct professional workflow, because this is important. Since Git and GitHub are used in almost all software development roles and in a lot of classes here at FSU. And this is an example of a professional workflow that is often followed. And I will also be mentioning some good practices that you should always keep in mind. So the correct professional workflow is to create a new branch, add commits, create pull requests, review, deploy, and finally merge, but merging should always be last. And branches allow you to work on new features or fixes in isolation from the main project. And a good practice with naming branches is to name them clearly and descriptively, like I was saying earlier. And it's also important to use a consistent naming convention across your entire team so it doesn't get confusing at all. And commits will save your changes to the branch that you're working on, creating a trackable history of your work. So it's good practice to make small incremental commits that capture a single logical change, but you never want to commit a version of something that isn't working properly, so keep that in mind as well. And it's also good practice to write clear, concise commit messages that explain your changes, because when you have to go through a pull request, your team is going to be looking at these commit messages, so you want to make sure that they're easy for someone else to understand if they're looking at it. And a pull request is a way, like I was saying, to inform your team about the changes you've made and to propose merging them into another branch. And this will also start the code review process. So reviewing pull requests ensures that the code meets the project standards before it's merged, and it's good practice to conduct thorough reviews that will include checking the code functionality, consistency, and maintainability. And deployment involves running your code in a production environment to ensure that it works as expected. And once your code has been reviewed, tested, and approved, it will finally be merged into the target branch. And it's good practice to delete the feature branch after merging to keep everything organized, because once it's been merged, you don't really have a use for it anymore. And I also just wanted to mention some helpful Git commands that you can use in the terminal that I didn't show before. So the first command, git log, will provide a comprehensive view of the commit history for the current branch, showing details like the commit author, date, and message, which is extremely helpful for if you need to revert back to a previous commit. And git diff is used to compare changes in your working directory against the stage changes or changes in the repository, which is also super helpful to see what files you've changed. And git revert allows you to reverse the effects of previous commits, creating a new commit that undoes those changes. So that's why the git log command is so helpful, which is you would be using git revert if you need to go back to a previous commit because you lost some work or something like that. And git reset is used to unstage files or go back to the previous state of the repository. So I also wanted to mention some helpful Unix commands that are really useful when you're using Git in the terminal. So cd, and then the name of the directory, is going to be used to change the current working directory to the specified directory, so you use it to navigate through the file system in a terminal. ls is used to list all files and directories within the current working directory. The make directory name command will create a new directory, which you all saw me do, and name it whatever name you want to do. And then the rm command can be used to remove files or directories. And then you can also use the mv command to move a file or a directory into another location. And you can also use it to rename files or directories. And then the man command is used to display the manual pages for Unix commands, which are essentially like help pages for different topics. And here are just some really helpful resources for using Git and GitHub. And there's also a lot of online resources, there's tons of resources on LinkedIn Learning. But GitHub honestly has a ton of documentation and very helpful resources for when you're first starting off. So I highly recommend looking there. But thank you so much for coming. And that's it for this workshop. So thank you so much.